Okay, look at the beautiful question on the board. We are told to find the derivative of this function. Now, we are still going to proceed with the same approach, okay? The first step is that we're going to reduce the function. For this, I'm going to have y is equals to the natural log of x raised to the power of x, okay, plus the natural log of sine raised to the power of x, negative natural log of 3 roots of ln x. I'm very sure you understand how I got to this point, okay? If you didn't understand, that means you didn't follow our previous class. So it is important that you revert back to those class and watch those videos. You understand? Okay, let us proceed. Now we have gotten to this point. According to this law, the log of a power is the product of that power and the log. Okay? Now, I want you to take note of this. If I have sine square x can be written as what? Sine x raised to the power of 2. Do you understand? So if I have sine cube x, it can be written as what? Sine x raised to the power of 3. Do you understand? And if I have, that means if I have sine, this can be written as sine x raised to the power of 5. Do you understand? Okay, let's proceed. For this, I'm going to have y is equals to ln x raised to the power of x plus ln sine x raised to the power of 5 minus. Now, I want to take note of this. If you have the root of root of x to the cube root of x, this can be written as x raised to the power of what? 1 over 3. Do you understand? Okay, let's do the same for this. For this, I'm going to have the natural log of ln x raised to the power of 1 over 3. Do you understand? Okay, let's proceed. And now, we can make use of this formula. We can make use of this rule. The rule states that the log of a power, that is when a log is raised to the power, that expression can be written as the product of that power and the log. Okay, let's proceed. For this, I'm going to have y is equals to, now, according to that law, this log is raised to the power of x. So I'm going to have x ln x. Do you understand? Okay, plus 5 ln sine x. Okay, minus 1 over 3 ln okay, minus 1 over 3 ln x. Okay, do you understand to this point? Now we have gotten to this point. Let us find the derivative of this function. So let me start from this part. I'm going to differentiate this part separately. Do you understand? Because I'm going to differentiate x ln x using the product rule. You understand? So let me write it here. Let u is equals to x ln x. Do you understand? Now I want to differentiate this using the product rule. The product rule states that derivative of v multiplied by u plus the derivative of u multiplied by v. We make use of the product rule when we have a function that has two parts and these two parts are multiplying each other. An example of that function is this. We have x is a first part and ln x is the second part of this function. Do you understand? Okay, let's differentiate this function. V is what? Ln x, and u is what? X. Do you understand? So derivative of v, which is the derivative of ln x, that is what? 1 over x multiplied by u. U is what? X. So I'm going to have 1 over x multiplied by x plus derivative of u. Derivative of u, if you differentiate x, you're going to get 1. So 1 multiplied by v, that is ln x. So 1 multiplied by ln x is what? Ln x. So I'm going to have ln x. Do you understand? If you don't understand how to differentiate using the product rule, go back to our previous class and watch the video, okay? So for this, I'm going to have 1 over x multiplied by x, that is what? 1. So I'm going to have 1 plus ln x. So I've differentiated this part. That is, derivative of y is equals to 1 plus ln x plus, okay. Now, for the second part, that is 5 ln sine x. I'm going to have 5 multiplied by ln sine x. If you want to differentiate ln sine x, don't forget, in our previous class, to find the derivative of a function that looks like this, we take the inverse of the function at the front of the natural log. Okay? So for this, I'm going to have 1 over sine x multiplied by the derivative of sine x. So if you differentiate sine x using the first principle, you are going to get cos x, okay? So I'm going to have cos x here minus 1 over 3 multiplied by, now we got for ln x, if you differentiate ln x, you're going to get 1 over x. Okay, let's proceed. The derivative of y now is what? 1 plus ln x plus 5 multiplied by cos x over sine x, cos x over sine x, minus 1 over 3x. Do you understand? Okay, now we can still simplify this further. Now in trigonometry, you know that sine x over cos x is what? Tan x. You know that in trigonometry, if you sine x over cos x is tan x. Now if you take the inverse of sine x over cos x, you are going to get what? Cos x over sine x. So the inverse of this, if you take the inverse, that inverse will give what? 1 over tan x. Do you understand? So the reason why I go to this part is because we are going to make use of this here, okay? I want to simplify this further. Now let's proceed. The derivative of y now becomes 1 plus ln x plus, now according to what we have here, the inverse of sine x over cos x is what? 1 over tan x, because cos x and sine x over cos x is what? Tan x. So for this I'm going to have 5 multiplied by 1 over tan x, 5 multiplied by 1 over tan x, and 5 multiplied by 1, that is 5. So for this I'm going to have 5 over tan x, okay? So I'm going to have 5 over tan x minus 1 over 3x. So the derivative of this function is this. Do you understand? Okay, let us proceed to the next question.